Today we'll be talking about the cylinder, actually how the surface area and the core surface area of a cylinder is being gotten. So we're talking about this shape. It's a solid shape. So a shape that is like this, a cylinder, a cylindrical shape, something in this order. So this is a cylinder. It watch out. It has two circular parts. Look at it. This on top of it, it has two circular parts. You've seen a 3 crown milk. Yeah, it's a cylinder. Okay, let me show you. This is our, you can see it. This is a cylinder, the shape of a cylinder, whereby look at the first circular part at the top and look at the base, right? A circular part. That's what I'm telling you. So you can see it. So this having two circular parts, I know that a circle has diameter. So and half of diameter is radius. So it means that from here to here is actually the radius, and from here to here is actually the radius. Does it make sense? And from here to here is actually the height of this cylinder, which is what? H, the perpendicular height. Does it make sense? Now we'll be looking at how the curved surface area, the curved surface area of a cylinder is being gotten, and how the total surface area of a cylinder is being gotten. Does it make sense? Very good. Now, the curved surface area is not talking about the circular part. Now, understand this thing. If I open the base of this cylinder, that's if I open this cylinder, the circular part, if I open here and I open here, okay, let me show you what I'm saying. So watch this thing out. This is a cylinder, right? This is a cylinder, and what can you see? It's a cylinder, something like that thing that I showed you. If you watch, this part is open and this part is equally open. It's just like a tunnel. You know, our motivational speakers, they say light is at the end of the tunnel. So why should it be here? So this is just like a tunnel, a hollow surface. So this part, the circular part, has been opened, is a cylinder, and here has been opened. Now, and I use an iron scissors to cut. If I use an iron scissors to cut this, what am I going to get? I'm going to get a shape that looks exactly like this. So it means that the curved surface part, which is this part is the curved surface part. This part, the curved surface part that you are seeing, and which is here. Not these are called the circular part. Do you understand? So it means that the curved surface part of a cylinder is actually formed with the shape of a rectangle. Does it sound good? Yes, it sounds good. So I have the curved surface part is formed with the shape of a rectangle, something in this order, a rectangle that it is like this. Does it make sense? And if you watch very well, if you watch closely, this thing, I said that from here to here is the height, which is from here to here. And that should be from here to here, which is the length of this is the length of the rectangle. And here is the what? The width. Does it make sense? Now, if you watch closely very well, from here to here is height of the curved surface part. And this same height of the curved surface part is actually what formed the, no, this same height is what formed the what? Watch out, let's explain this thing better. If you watch, this is the cylinder. It is formed like this. So we have a hollow surface like this. So and the curved surface part is from here to here, right? Now this curved surface part from here to here of the cylinder is the height of the cylinder. And if you open this thing, and which is from the height, if you open this thing, you will see that this thing from here to here is actually what formed the what? Is actually what formed the width of the rectangle. So if I know, I would have drawn this thing like this. Okay, it will make sense like this. So we have that here is length and here is the width of the rectangle. Now, and from here to here, which is the height of the cylinder, is what actually forms the width of the rectangle. So it means that the width of the rectangle is equals to the height of the cylinder, because the curved surface part is formed by a rectangle. Does it make sense? It should. Now, if you watch again, the length, if you watch the length of the rectangle, which is from here to here, if you close this thing, now watch out. Where is the length of the rectangle from here to here? If I ever close this thing, what does it form? It is the something that formed the circumference of the circular top. Now, the circumference of the circular top, since it's a circle, the formula of getting the circumference, it means that the length is equals the circumference. The formula of getting circumference is actually 2 pi what? R. Is that true? The formula of getting circumference of a circle. So it means that the length is given by the formula 2 pi R. Does it make sense? So when I'm having the curved surface area of a cylinder, since the curved surface area, so since the curved surface is made by a rectangle, you can say that the formula of the curved surface is actually length times width, the area, because of this area. Now, if you want to get the form as in the formula in terms of R and H, that should be 2 pi R. That's length is actually 2 pi R. Then the width is actually what? H. So most times you see that the formula of the curved surface area of a cylinder is actually 2 pi RH, and that's very correct. I hope you understand something. Now, the total surface area of a cylinder actually have conditions. You see a place whereby they'll tell you that one end is open, one end is what? Opened. And you know, if one end, that's for here and here. If one end is open, it means that one of the ends is what? Closed. So I have one end is what? We have that one end is open, or when one end is what? Closed, right? Now we have another condition which says when both ends are closed. That's the second condition, I mean. So watch what I mean. If you have a cylinder and we ask to find the total surface area, a time will come whereby they tell you that one end is open and one end is closed. You know that a cylinder is made up of a circular part, a curved surface part, and two circular parts, right? A time will come whereby they will open here, the top, and here will be intact. They open the top and here will be intact. So something like that, if you want to find the total surface area, it will be the curved surface area plus area of this place that is intact. Does it make sense? So here it will be what? The formula of getting the total surface area of a cylinder when one end is open or when one end is closed will be what? The curved surface area plus area of one circular part. Now, when both ends are closed, that's when here is intact, like the one I showed you. When here is intact and here is actually intact as well, the area will still be, the total surface area will still be the curved surface area plus the area of the two circular parts. That's the curved surface area plus the area of what? The two circular parts. Does it make sense? So the formula here will now be the curved surface area, which is the 2 pi ROH plus area of one of the circular parts. Circular parts, one of them is a circle, that's pi r squared. Area of a circle, that's what? Pi r squared. I hope you understand. Now, when both ends are closed, it will be the curved surface area, which is 2 pi ROH plus area of the two circular parts. That will actually be area of two circles now. That should be 2 pi r squared. So I know you understand how, by now, if you understand how the curved surface area and the total surface area of a cylinder we are being gotten. Does it make sense? So I would like you to help me by subscribing to my YouTube channel, follow my Facebook page, even on TikTok. Please have a nice day.